Hello friends, I'm here with another question from JEST 2020. This question is from mathematical physics and it is about Fourier transform. The question reads, if ft is a real and even function of t, which one of the following statements is true about its Fourier transform? So the most important thing here seems to be Fourier transform. What is a Fourier transform? Well, by definition, a Fourier transform is integration from minus infinity to infinity, the function that we need to transform, e to the power I omega t times dt with respect to dt, and we usually have a constant. Now, if you need to do a Fourier transform on ft, or if you want the Fourier transform of ft, you simply integrate it this way and get the Fourier transform. Next, we have real and even function of t. Now, a real function is something that has no complex part in it, and also that the complex conjugate of a real function would be the real function itself, right? And even function. An even function is symmetrical both sides of 0. Okay, like x square is an even function, whereas x cube x is an odd function. Similarly, sine is an odd function, cos is an even function. To know more about even and odd functions and how it pans out, you can check the video from the links in the description below. So we'll write a few things here in that cos is an even function, sine is an odd function. Now here, if you look here, we have got three options in which we have got conjugates. So conjugates seem to be important. I'll first resolve this thing into one component that's real and another component that's complex. Now what I'll use to do that is I'll use this basic formula from complex analysis, e to the power I omega t equals cos omega t plus I times sine omega t. So what I get here is integration minus infinity to infinity half of t cos omega t dt plus minus infinity to infinity half of t sine omega t dt, and I is the imaginary number. Now if you look at this portion, then what happens is ft, we are told, is an even function, and sine, we know sine to be an odd function. Now if you are multiplying an even function with an odd function, what you get is an odd function. The nice thing about odd functions is that when you integrate them over symmetrical regions, they come out to be 0. This integration from minus infinity to infinity will make all of this thing as 0. So the only thing I have here left is f of omega equals to 1 by root of 2 pi integration from minus infinity to infinity f of t cos omega t dt. Now if I try to find the conjugate of this thing, then nothing is complex here. There is no imaginary quantity. So the conjugate of f asterisk of the Fourier transform will simply be the same thing as f of a capital F of omega, or the Fourier transform. So what we have is f asterisk omega equals to f omega, and that is here. So this is our answer for the above problem.